projects that are being artificial intelligence and drone for security and surveillance. And I'm sure this is going to be a very interesting topic today. Over to you, sir.
Thank you very much, Professor Gowda. Thank you for your introduction. I will now share my presentation. Hopefully it will come up. Is that visible?
Yes, sir.
Thank you very much. So I just wanted to once again thank you for Professor Gowda to invite me to speak on this webinar, and it's my pleasure to be able to present to you from Australia to give you some ideas about some of the projects we are doing in related to artificial intelligence. The topic of my presentation today is towards AI for the global good. And as the presentation goes on, I'm hoping that I'll be able to explain to you why I've chosen that title, because there is a lot of great work happening in AI across the world, but also there are some challenges in AI as well. So before I proceed with the part of the presentation around the projects that I would like to show, I'd just like to give you an idea for those of you who don't know UTS, or as they call it, the University of Technology Sydney in Australia, and I wanted to give you a very, very brief introduction about that. So we are a university in the centre of Sydney, which is the largest city in Australia, as some of you know. It is a very young university, only established officially in 1988, and we have a growing campus in the city, including some beautiful buildings that are built into the fabric of the city infrastructure. So we now have, I think, over 45,000 students in total. Of course, the situation now is a bit more difficult with the COVID crisis, so some international students, unfortunately, are not able to join. But in general, that is the standard number we have, and we have many undergraduate and postgraduate courses. So I'd also like to give you a little bit of information about our faculty profile. So I wanted to be brief here, but we're very proud of some of the achievements we have done in the university, and I'm in the Faculty of Engineering and IT. So the biggest thing we're proud of is in the academic ranking of world universities, or used to be called the Shanghai Jiaotong ranking. We are ranked #1 in Australia for computer science, and also 29th in the world globally, just under Cambridge. So we're very proud of also our telecommunications engineering and electrical engineering. Also, in terms of our ranking for just broadly engineering and technology, we're in the top 10 in Australia by the Times Higher Education rankings. And in the Times Higher Education rankings, we're #2 in Australia and 74th globally. Also the QS subject rankings and also the CWTS Leiden rankings, we score well. So we're very proud to have so many really outstanding researchers who undertake their research in the computer science field. I'm going to show you today some of the work we do, generally speaking, into my laboratory, but actually there is so many different projects and different research in AI in our university that I could not even share that with you for even, it would take me many hours to do that. So, for example, we have approximately 100 academic staff in our Centre for Artificial Intelligence, which has now become an institute. We have also got the same number of researchers in data science. So we have one of the largest critical mass in those areas, but also we have had many visitors come to India to deliver presentations. Unfortunately now, this is the best way to deliver the presentation under the current crisis, but I hope everyone is well, and I hope you will enjoy this presentation. So I just wanted to talk to you a little bit about our Intelligent Drone Lab. So the Intelligent Drone Lab sits within our Centre for Artificial Intelligence, and we have a number of staff. I am a co-director with Dr. Nabin Sharma, and it's the first laboratory of its kind in Australia to facilitate research and development in making drones, or as they are also called, UAVs, autonomous. So you may be aware that drone is actually a term that's used very in a colloquial way, but actually UAV or unmanned aerial vehicle is the more traditional way of saying it. But basically our work looks at empowering drones with software to do intelligent things, and our mode is usually with the introduction of artificial intelligence. So we do a number of things, including we are looking towards drone license training as one of our areas. Sorry, I'll just go back. We're looking also at degrees, diplomas, and certificates in flying. And we actually have an industry partner that helps us called the Ripper Group, and I'll explain them a little bit later in the presentation. But also we have a very strong focus on R&D in the computer vision and machine learning space for autonomous flights of drones. So that's one of the big, big foci of the Intelligent Drone Lab. Later in the presentation, we have a very strong focus on R&D collaboration in the computer vision and machine infrastructure management to security, also to wildlife management and analysis. And I'll show you some examples of that in the second half of my presentation. But I wanted to start with the presentation with another some work I have done and am still undertaking from the federal government's funded scheme called the Australian Research Council. But before I do that, I just wanted to talk to you a little bit about my definition and general feeling about artificial intelligence. So when I talk to companies, a lot of people think that AI has recently, come about. But firstly, it hasn't. AI has been around for a very long time, and we all know, those of us who do research, how much has been invested in time and many years undertaking AI, in the form of neural networks, symbolic AI, expert systems. I mean, the history goes back many, many, many decades. But a lot of people in the industry are not aware of that, or at least they say they're not aware of it. There is also no general AI technology currently available. Unfortunately, some of the vendors that sell AI products, and I'm not picking on industry per se, but we as researchers, I assume many of you are researchers in the audience, are very much, understand that it takes a long time to develop these algorithms, and certainly there is no general AI algorithm for any of this. So that technology is still far away. And of course, it's very important to know that you can't develop a good AI system, in an easy way. There is no silver bullet. And of course, there are many startups and companies that they say they have the answer. But I would argue that most of the good research and achievements for AI is actually sitting in our university research labs. And that's why I always try and convince people that there is a lot of great work that is untapped and sometimes is tapped in our research laboratories. So I just wanted to, usually I leave this slide for the end of the presentation, but I wanted to reflect on the fact that AI will undergo a transformation soon, right? It's not going to be the same that it has been for the last 5 years. So everyone knows that in 2014 we had the discovery of deep learning, and that has been used very successfully in many applications. But a lot of people don't realize that deep learning has many flaws, and it's certainly not the final answer to everything. At the moment, it's giving us great results. That is definite. And I will show you some from our research lab. But the reality is, though, we always wanted to be able to develop AI that mimics the function of the human brain, and actually has some really unique element that actually mimics the human. That's what our big holy grail is. So there are some pieces of work occurring in the world that are very much trying to push the boundary and not just end the AI story at deep learning, but actually go beyond it. So of course, we all know that deep learning consumes a lot of, data and is sometimes slow in training. So we all know that that's a very challenging problem. So there are researchers like Hinton in North America that's looking for ways in which we can create neural-based techniques with less training samples and yet be more closer to the human brain. So that's for algorithms. So trying to get away from the standard concept of very data-hungry deep learning technologies. So that's a big area. Another big area that you may have heard of is neuromorphic computing or neuromorphic AI. This is focusing, because if you're in the computer sciences, you focus on the software and the algorithms. But what about the hardware? There is also an equal appetite for chips that are going to be brain-inspired, brain-like, and can also mimic neurons in a way that are digital, but have less power consumption and are faster. So neuromorphic AI is the concept of trying to establish, more, again, human-like neurons, but it's still on a chip, and be more brain-inspired. And if you manage to put the software and the hardware together, you should have a much more powerful computing system for mimicking AI or to solve AI problems. But that's still, being under development. So just as we are still developing the software and the algorithms, we're also concurrently developing the hardware. And I also wanted to just talk to you about one last thing, which is quantum AI. So some of you may not know that quantum AI is actually it's establishing itself as a new area for doing artificial intelligence. So we all know that quantum computers have not yet been created to solve problems at scale. We can solve very tiny problems with like the IBM computer or the Microsoft algorithms, but actually quantum is still very, very nascent. But basically, if the problems can be solved from quantum computing, it is possible that quantum AI will be the next generation of very advanced research in AI, because basically you'll be able to have a computer that can undertake, a quantum computer that can undertake calculations at a very significant rate in terms of speed and accuracy. But this will also allow us to propel AI to the next dimension. But we haven't got there yet. But there are some researchers in my university in the Quantum Software and Information Center that are actually already looking at developing programming environments for quantum, and already looking at testing and verification of quantum algorithms. So the research, the link that you have there, you're welcome to copy it down and have a look at it, is the starting point of trying to look at a programming environment and a compiler to create the new generation of software in an emulator initially for quantum computing. So the future of AI is very, very bright. It is extremely bright indeed. But one of the reasons I wanted to talk about my title of AI for the global good, is because although the future is very promising and exciting, there is a lot of talk around the world at the moment in the area of AI and ethics. So you've probably heard about that. A lot of people talk about, we can't really develop AI algorithms which are biased to a particular person or group, or that give results which may be detrimental to humans and potentially violating their human rights. Now, I agree with all that, but the problem is the many people who are supporting that story of AI that needs to be very ethically and tightly, scrutinized, is actually missing the point that although that is extremely important to have ethics in our AI, the reality is a lot of the AI we do is actually not transparent. It's actually, it is actually opaque. There is black boxes, but a lot of people are now also moving into things like explainable AI. But the reality is that right now the successes have been using generally connectionist or neural-based technology to support the good results that we've seen. And so look, it's right that some people are worried, but I think it's wrong to say we should stop developing new technology and being successful. for the point of creating new frontiers, because I believe that there is more good that has occurred from AI than bad. And I think we should really celebrate the good. And that's why I wanted to talk about towards AI for the global good. So I'll go to my first example of my presentation, which is a grant that we ended up having with what's called the Australian Research Council. It is a very, it's like the federal fund for supporting research grants in Australia. It's like the NSF in America and so forth. And we created, we were successful in receiving a grant in the topic of predicting household water consumption events. And it sounds like a very, pedestrian topic, but actually there is a really important thing as part of the foundation of this grant, which I think is actually appealing to both our countries. It's appealing to Australia because we have both our countries have water as a very short resource. Okay, so if I go to sorry, let me see. If I just go to here, this slide here, very important to note that our world has a scarcity in water, and it is probably one of the largest global risks in the world. I mean, right now it may seem that it's not, because so many people unfortunately are also falling victim to COVID. So the largest global risk right now is still COVID. But once COVID is hopefully extinguished soon, we still are left with many resources in our world that are not unlimited. And water scarcity is one of those problems. Now, in Australia, we have this thing called water restrictions. And I remember that recently we had level 1 water restrictions, and they went to level 2 and level 3. What that means is basically that, we are restricted to how we can use water in Australia. And that's because it's just unfortunate that, we had a drought recently in Australia, and you might have seen we had bushfires as well in towards the end of last year. So we had many issues in Australia, bushfires, and then, water restrictions, and then COVID. So, every country has its problems. But one of the biggest issues is that our water utilities don't know how to manage demand for the situation of water usage in peak hours. So this is very important, because if we're going to use water and have it available, we need to be able to know how to use it in a way that actually is beneficial for people, but also is managing the scarce water that exists. So one of the solutions we came up with was using a digital water meter, which is a meter that's installed at the house or residence or university or business, whatever it is, to look at what's happening inside the usage of the water of that establishment. So, the problem is that, so this is the big problem, is that how do you actually take individual water use and make it more useful? Because, there are countries that have digital water meters. I don't know what the status is for India and in parts of India, but certainly in Australia, there is only some parts that have digital water meters to measure the usage of water in households. And the problem is, how do you use that information to facilitate better conservation of water and individuals' water? And how can the digital water meter data actually influence the behavior of people? So I just want to go back a couple of slides and just show you the research. So we've published a few papers already now from this ARC Linkage Project, or LP. We developed some software called AutoFlow, and it used machine learning techniques to, so here is one example of AI for the purpose of trying to solve a big global problem. So it's for the global good, but it focuses on water. And as you can see, we actually have used this software we've developed to look at the usage of people's water in a household by the actual category of activity. So a clothes washer, a dishwasher, a wash closet, an evaporator cooler, shower, tap, bathtub, and we can actually from the signals generated from the digital water meter and from the signals obtained from different parts of the house, we are able to actually correctly categorize which type of activity is happening in the house. Now, why would we want to capture this? It's so that we can know what is and so you can see there the accuracy is in many cases above 90%. And the idea is that we feed the machine learning system some data, and we're able to predict or should I say we're able to accurately recognize what one particular activity is. Is it a toilet flush? Is it a dishwasher? Or is it something else? And what that allows us to do is to be able to monitor also the problems of what we call leakage. So that's the big problem in Australia. We have many, many houses that leak water, and that means the water just disappears. And so one of the reasons for this research was to actually see if we could detect the different types of water usage and distinguishing them from leaks. If we could find the leaks, we could then inform the water utility, and then we could solve the problem of the issue of losing water and having a problem with water scarcity. So the next step, though, is what we created in our project with one of my research team and PhD student. We have a sub project within the Linkage Project that only focuses on what we call a recommender system. So the recommender system is about saying, okay, we know all this water usage, we know when it's being used. Now, how do we actually change the mindset to motivate consumers to actually try and shift their water behaviors? Now, I know that sounds like a very difficult proposition because firstly, if someone has to go to work, they have to shower in the morning and that's it. How are you going to shift their behavior? But what happens if you can provide incentives to try and get everyone to shift away from the heavy water consumption activities so that you don't have as much water demand, you reduce it during peak hours? Well, the only way we could think of that we could do that is if we had a recommender system that could be visible to a consumer of water. Say the head of the household gets a bill, but on the bill it says, look, if you actually shift your shower time from here to here, we might be able to give you some rebate or reward. And the recommender system can give them an intelligent way of saying, look, we can give you a recommendation. If you shift only by 15 minutes or by half an hour, if you cut down your time of your shower to 6 minutes or 4 minutes, whatever it may be, we will give you a reward. Now, keep in mind, this is all still hypothetical, but we're in discussions with our water utilities in Australia already about trying to implement this in a more practical way. But so far, we wanted to actually prove that the technology could work, and then we'll be able to hopefully partner with a utility and provide that opportunity. So obviously, the benefits of a recommender system are very clear. Consumers will be able to achieve more water savings behaviors. They can increase in consumer satisfaction in two ways, by hopefully getting rewards, but also certainly in Australia, we found that there are many young people that are very worried about the future of the environment. They're very worried about climate change. So they'll actually want to do some of these activities. And if we give them custom tailored recommendations, they can take those recommendations and then hopefully use them to also help save precious water, but also in the environment and mitigate climate change. So the other good thing about the recommender system is that, I'm sure that in India, just like in many countries, the conversations between water utilities is usually focused around bills. So in our country, or any utility, should I say, electricity or whatever the utility is. In Australia, we pay for water and we pay for water consumption. We have a bill arrives and we just have to pay it. There's nothing we can do about it. So if we pay it, then that's it. The transaction is gone. But imagine if the water utility had a conversation with you and said, look, I'd like to give you some ideas for how you can save water, save your bill, and also save the environment. So if we could do it in such a way where the conversation is very open through maybe an automatic system like a recommender system, that would be one way to do it, and that would be hopefully something that can happen in the future. So here are some aims of and our objectives. We wanted a knowledge-based recommender system to promote more effective water conservation. We wanted to reduce or shift high water consumption events. Very important. Shower, bathtub, so forth. Because if we shift it from the peak, then we'll prevent water shortages and low water pressure, and customer unsatisfaction is gone. So we also this is a really important one. It's the prediction also of anticipating high water consumption events. So what happens if everyone turns their tap on in the morning at 7 o'clock? There could be big problems with that on the water system, and the water utilities will know that. So what we decided was to use an LSTM, or a long short-term memory recurrent neural network, for predicting events. So we know what events are there. We know how long they take. Now we're going to use a recommender system which is powered by a recurrent neural network for predicting events in the future. And all of the big goal here is to mitigate the water crisis. That's the big goal. So here's an overview of a recommender system. So not only do we detect leaks with the previous work that I mentioned earlier, but we also now have a prototype which looks similar to this, but this one is a bit of an earlier version of what kind of recommendations someone could have. So firstly, it tells you what you did in terms of what your water consumption was and when it was, and then it gives like a list of top 5 recommendations, for example here, which then can be, you can see here, if you achieve this, then you can actually get some rewards. And so you can see the top one there is if you shift your shower time between 6:30 and 7 instead of 7 to 7:30, you can get 10 points by this system. Now, keep in mind, this is just a prototype, but it's showing that the more you put up your activity, some things are more beneficial than others. So certainly shifting your shower time is much more beneficial, and cutting your shower time down to 4 minutes gives the second highest number of points, which is 7 points. So, there are 2 ways which we can make recommendations. We can provide a custom tailored list of recommendations on the basis of water activity. We can also provide non-personalized recommendations based on summary statistics to perform a comparison. So actually, you can actually see what everyone else is doing, but in an aggregated way. So there's no privacy concerns. It's just that you can see the rest of the community that you live in, if everyone has a digital water meter installed, to get an aggregate version of how you're performing against somebody else. And there are implicit and explicit ratings. So you can have ratings from water consumption patterns, but then you could also provide some ratings explicitly through the web interface. And the big part of this is actually being able to have a reward and rebate point system, because that is really what will motivate people to change their activities. So as I said, the benefits are for the consumer, increased customer engagement, increased effectiveness compared to other programs, should save both water and money. So as I said, in Australia, we pay for water, and we would save money for people if you do it properly. Also, it's a direct medium of communication with water utilities and increases the consumer's satisfaction levels. And the last thing there, water utilities. They will have a reduction in water demand in peak hours. It will lead to efficient pumping activities, decrease operational costs, better understanding of their consumers, and effectively devise and convey water restrictions, which is really necessary, particularly if you are in a water restricted situation like Australia was in recent times. So there are some challenges. Look, it's not possible to do research without having some massive challenges. So one of the biggest challenges is identifying the water consumption patterns and then anticipating the time of the next water usage event of interest. That's a challenge, because it's not really possible unless you have some AI or something, and of course you've got sufficient data to predict usage. Implicit feedback extraction from water consumption data is hard. So you can certainly try to take the data and make it useful, but it's not easy. It's certainly a challenge. This whole business of clustering of consumers and being able to actually use different consumers' data with similar consumption patterns to compare with yourself would be good. But again, it's hard because not everyone will have a digital water meter and not everyone will function perfectly and so forth. So there's always challenges. And one of the biggest things I think is the ensuring the system is scalable and reliable. And scalability is hard. And then integrating the recommender system based on demographic data, so taking the whole demographic of your area, again, not very easy. So you also have to, the last point there on the right-hand side here is the limiting the number of recommendations. If you recommend 10, 20 things, the consumer will become bored. But if you recommend top 5 that have very good opportunity for success or good value or benefit for both parties, that's the best way to do it. So you have to prioritize and explicitly determine which are your important recommendations and which are the most important to list for the consumer. So look, we did I just wanted to give you some information about the proposed approach and the experimental settings for our technology. So we have, as I said, a software system called AutoFlow, which was actually created on the basis of the broader ARC Linkage Project, or the main project. And we could categorize water events based on the data we collected from a number of households. In this case, there were 83 households for 7 months of water consumption. The classifications were successfully undertaken for different things, including random events such as leaks and other problems where there is less water consumption, but it can be very dangerous if you keep it on. So if you have a leak forever, it may only leak a little bit, but if you count that over a year, that's going to be very problematic. Also, cyclic events. So things like clothes washing, dishwashers, these occur, many times in a cycle, and so they were aggregated. And we also finally had to do some dimension reduction. So we looked at the start date, start time, and category attributes were considered for the events themselves. So that was the main part of the data set collection and pre-processing. We then actually had the real important part of the experiments, the proposed approach and experimental settings. So as I mentioned, we prepared the data set for use with a LSTM or LSTM recurrent neural network. And so we framed the data set as a supervised learning problem. We had different lag observations. So T-1, T-2, T-3, and then one column of forecast observations, T+1. So this was to ensure that we could, so it's basically a time series consideration. And the categories were label encoded using an integer encoder. So we used a very simple LSTM network, and we then had 50 neurons in the first layer, 1 neuron in the output layer. We had a training and testing split of 60-40, and we looked at the mean absolute error, so loss function and efficient atom optimization functions for determining whether an LSTM for this problem is suitable. So keep in mind that at this point, we only tried our first, we only tried our first component of our research, our first step, because we've got many more steps to go. But it's this step here, which I'll show you. It's the step I mentioned here to do with, anticipating the time of the next event under consumption patterns. So can it be done? The question was, the research question, can it be done with a neural network with this data that we have? And remember, the data is not a huge data set, 83 households only, but there's a large number of events that we captured. So we're very fortunate that figure 2 shows a sample loss of the LSTM model, and it shows that for training and validation for a sample household, it performed well. The error was well reduced, and we were able to demonstrate that it was possible through training to actually come to converge to a successful answer. Also, we tried to measure stability on the basis of comparing the best RMSE, or root mean squared error, with the average root mean squared error. And as you can see, it's pretty stable. So we actually found that training could converge. We did a number of runs to assess the quality and the stability of the system on the basis of the data, and we found very positive results. So this is just the first step. Our next steps now, which we have started doing many more new work, is to actually operationalize this into a working predictive system. But this work here that I'm explaining shows that the LSTM is a very good candidate for predicting household water consumption events, and therefore was perfect for us to then take to the next step. So in conclusion, this particular work was presented as a paper, and it was a novel concept of a recommender system for promoting water conscious behaviors. So there are many recommender systems around, but this was the first time that a recommender system was used for prediction of behavior in terms of water consumption. It's the first one that uses data in this way to be able to do that. So basically the system, if it's implemented, which is our next steps, the project will end by July next year, and we are hoping by then we'll have a working prototype that we'll be able to demonstrate to water utilities and other utilities. So it should benefit not only water utilities but also the consumer. And we confirm that when we anticipated the next water event, you can see from the stability of the system that LSTM is a good candidate for that. So we now need to actually do more work. We need to look at training the single LSTM model for similar households. We need to look at investigating the marked temporal point process. We need to look at different approaches to be able to take this preliminary result and scale this up to a level that will be possible to scale it across multiple households, multiple suburbs, multiple cities, if possible. Whoever can have a digital water meter, and if the water utility works together, we can have a good result. So basically, this is one case study I wanted to show you, because I really believe that there was no issues with privacy. There was no issues with any problems with the data not being appropriately cleansed or aggregated, or it was definitely there was no identifiable information. So it shows that this AI application is for the good of preservation of water, and if it succeeds, we could actually see this working on a more national and possibly, hopefully, global scale as well. So I wanted to show you that as my first case study. Now here comes the second case study. As I mentioned, Professor Gowda introduced me at the start of the presentation with some of the work we've been doing with UAVs and drones. I wanted to save the best case study to last, because this one is always very interesting to people, even people who don't have sharks in their backyard. They love this technology. There's been a lot of presentation of this work around the world, and we've been very fortunate that it's been a very successful system. So SharkSpotter is what I wanted to show you now, and it's the world's first automatic real-time artificially intelligent shark detection system for UAVs. So why do we need shark detection? Why is it so important? Well, because in Australia particularly, shark attacks have been a very emotional issue and political one. So it's not just that, it's also the fact that we want to provide security and safety around our beaches. In Australia, we have 11,000 beaches. Our country is obviously a fully, an island, basically. So we are surrounded by beaches across the whole of the country. So obviously, there are many beaches, but many of them are actually unpatrolled. So if you look at the statistics, these are some older statistics, but they're about the same from one year to the next. We have 17 unprovoked cases, 2 provoked cases, and 11 injuries, 1 fatality, and 7 uninjured in 2017. Now, that doesn't seem like the statistics are overly concerning, but the problem with shark attacks is that they're terrifying, and people are terrified of sharks. Also, the fatality is horrible. The fact that any person can be fatally wounded and die from a consequence of a shark attack is not something we would like to see continue. So a lot of the research has to do with safety, the political issue that it plays, and also the well-being and security of our beaches. So the current challenges, there are many, many challenges in Australia. At the moment, many of the responses to shark attacks occur on the basis of helicopter or aerial patrols. Problem is it's very high cost and very low accuracy. It's about 20% accuracy. So that goes to show you that that's really a challenge. We also have here what we have shark nets. Now, many places in Australia have shark nets, but they are destructive. They may be able to trap a shark, but firstly, do we want to kill the shark? Well, although people are scared of sharks, a shark plays a very important part in our ecosystem. Also, what happens if you trap turtles or dolphins? Then it's a really big problem for us. So from an environmental point of view, it's very bad. Beach patrols, well, again, if you look at these 2 lifeguards, they're looking straight onto the beach, straight ahead. Very difficult to see sharks. At the moment, there is no working technology solution that will solve this problem. So the question here is, can artificial intelligence and machine learning help to solve the problem? So everyone is using drones these days. Drones are very impressive. Some of them are very big, some of them are small, some of them can carry payloads. This one that I'm showing you on the screen, it can carry a payload of up to, I think, 5 kilograms. So, but it's unintelligent. I mean, it can fly, it's controlled, but there is no ability for it to determine, for it to see a shark. It's not possible to do that. So at the moment, there's no real-time video frame processing. It can carry a payload of up to, I think, 5 kilograms. So there's also no solution. It's unintelligent. I mean, it can fly with the marine ecosystem. But there is because, at the end of the day, we want to augment for it to determine. We don't want to replace life sharks. We want to augment their performance. We want to there's no real-time video frame processing. Carry a payload of up to, of course, most 5 kilograms. Cost-effective. So there's also no solution. It's unintelligent. To scale with the marine ecosystem, regional areas. But there is no ability for it to determine. We don't want to replace. We need to be able to expand from large cities to regional areas as well. So have a look at these 3 images. I'm not sure how clearly you can see them because the webinar is obviously, it's being transmitted over the web, and sometimes you can't see some things. So do you think you can easily see the shark in each of those photos? Well, the first one, I think you should hopefully be able to see the shark here, right? It's right underneath a surfer. That's very scary if the surfer knew what was happening. What about in this one? Can you see a shark? And what about in this one? Even worse. Can't really. Is there any? So this is the problem. The problem is that now I've got the red. You should see some red circles. Obviously, that one we saw earlier. This one looked like a shadow, but actually is a shark. Again, here's a surfer paddling towards that shadow. And lastly, here's a person doing skiing on water, and the shark is following. But it's really hard to see because look at the bottom of the ocean and the contrast is not very good. So So we have to solve all those problems if we have to create a shark detection solution, because even for non-automated processes from a visual view, that's really hard. So what's SharkSpotter? Well, when we set out to create it 2 years ago, we created a custom end-to-end deep learning technique for being able to intelligently analyze real-time video frames. And what we were trying to do was augment human performance. So remember, again, I want to talk about the theme of towards AI for the public good or the global good. We're not looking to create AI necessarily in these examples to try and replace human beings. In these examples, we're saying, look, we have lifeguards on the beach. They're already doing a great job, but they can't see sharks. It's very difficult from their angle. Even if they're in a helicopter, they can't see the sharks. So the objective of this system was to be able to augment the performance of the human with a 90% accuracy. And that was to detect, as well as possible, 16 different objects. So different marine animals, sharks, humans, and even drones on the beach. So this is the SharkSpotter solution we developed. We put on board, well, actually, in this case, it wasn't on board per se, but it streamed from video from a camera to see, say, this this patch on the bottom right-hand corner of your screen where you can see the surfer and the two sharks. And it then could broadcast that to a box which could then recognize the sharks or detect the sharks. And we created a very simple user interface on the left-hand side here for the lifeguards. So start detection, end detection, very simple app to enable the user, which is usually just a lifeguard that is not necessarily has a technology background, to be able to use something simple. And if they see a shark, to be able to send an alert, send an SMS, or do something else. So to give you an idea of the progress we've had, by December 7, 2017, so it's been quite a long time, the pilot was deployed at 15 beaches in New South Wales and Queensland. New South Wales is where Sydney is, and Queensland is in the northern part of Australia. We had successful trials also conducted overseas. At Reunion Island, we had a successful trial. And so Reunion Island is actually an island which belongs to France. It's in the Pacific. And it actually has one of the biggest shark problems in the world. In fact, some people call it Shark Island. So we actually conducted some successful trials there to enable swimmers to be safe and beachgoers to be safe. At the moment, it's actually illegal to go swimming sometimes on Reunion Island. So having a system to try and mitigate that problem is very important. There were 2 deployment solutions we developed. So my team and I, which the lead of that is Dr. Nabin Sharma, who created the SharkSpotter computing box, which is in operation. The cloud-based deployment was software as a service, and it's still under testing, but we've successfully implemented it now. And we've already undertaken some successful collaborations with Reunion Island, Cape Cod, Hawaii, and others. So what we see now is SharkSpotter deployed at 15 beaches, all the way up to in December 2017. We have successful trials conducted at Reunion Island, so overseas. And we then, towards the end of last year, we had the first iteration of the SharkSpotter software as a service cloud solution, which was powered by AWS. So that was probably one of the biggest milestones in our research. And why is that? Why is that so important? Well, because we no longer have to have a box. It could automatically transmit the video and undertake the calculations in the cloud. There was no box that needed to be associated with it. No power supply on the beach, as long as there's an internet connection, it could function, and that is the important. The other thing is, I'm not sure if it's mentioned here. Well, let's have a look at this demo first. Hopefully, you can see the video is going. This gives you an idea of what the sort of the operator sees. They see a screen with viewing of different video coming to their operator screen, but also so they can see it on their controller screen, but also on their operator screen. They can see everything that is shown here. They can see the water, they can see the detection of the shark. And then they'll know while they're flying their drone whether, so that was the tough one there, the boat, the surfer, and the shark following the boat, they were able to make a decision what to do. If they see a shark close to the beach, they can quickly sound an alarm. They can quickly notify the authorities. They can tell swimmers to leave. So it's very, very important for beach safety. So we were very fortunate. We ended up having many successes when this first was released. In 2018, we won 3 New South Wales awards. For the Australian Information Industry Association had what's called the I Awards, which is a yearly award for research or industry collaboration that's done. So we actually won the Artificial Intelligence and Machine Learning Project of the Year. We also won the R&D Project of the Year and the Community Services Markets because this was a community service support. This allowed us to actually support lifeguards, support the communities, and so forth. But interestingly, we then won the national award. So in the whole of Australia, we won the award so that we could then be the #1 machine learning and artificial intelligence project of the year in Australia for 2018. So we're very proud of that. But we kept going, and actually we then went the final stage of our success. We were very proud is that we actually went in to compete against 300 different systems, 17 or 18 countries in the Asia Pacific region. It was held in 2018 in Guangzhou, and we actually won the Merit Award. So we came second, but what was really exciting is that in comparison to 300 other technologies from across 18 countries, we were able to, be successful in our category for AI, coming in with a merit certificate. So we're very excited about that. The other thing that's really important is that we've actually had a lot of, we've had a lot of success in the media. So, for example, we actually ended up having some, probably, hundreds of thousands, if not millions, of media views of our work. If you look at the bottom right-hand corner, one of the big things that occurred in January 2018 was that we saved 2 people in New South Wales that were actually drowning. And one way they were saved was, it was because we dropped some, so I don't know if you saw, I'll go back to an earlier slide. See this, if you see this, what's called a payload, this is actually, it's sitting under the drone. You can see a yellow bag. It actually is a self-inflating device that you can drop for people who are trapped in the water or in a rip or having some problems, and they can actually grab a hold of that and actually swim to safety. So when this news on BBC was actually done, because what happened was we were the first ever drone savior of 2 Australian swimmers by a drone. So this is the first time in history that an automated process helped swimmers in danger. And that's interesting because, again, I want to point out the importance of AI being for the global good, and it's there to save lives, it's there to help people, and it's not there for the other means, So So we had many other, we had Reuters, we had New York Times, National Geographic, World Economic Forum, and even the Times of India did a very big feature. I think it was last year or the year before of the technical lead of our project, Dr. Naveen Sharma, who also has studied and worked in India and was born in India, and now is working here at UTS. But we did a whole profile of him in the Times of India, which was very encouraging, and it was nice to see. So apart from that, we've in 2018 we were ranked among the top 5 technologies in security innovation. Interestingly, one group of people looked at our work and said, "Well, you're saving lives, you're looking at sharks, but actually you could be used for security purposes." So they looked at that as an area of which we could actually be also leading in, and it was actually also voted one of the top ideas for using drones for detecting sharks from aerial imagery. So we've done a number of, luckily the media has been very positive and really promoted the idea of not only looking at sharks in a non-invasive way, protecting people and not destroying the environment. So we were very lucky. But actually, and so we have a couple of publications from that, and we have another publication which is coming. But obviously, the thing I wanted to mention, this is actually a commercial piece of work. So we've actually developed this for a company called the Ripper Group. And this work is therefore, although we've been fortunate we could publish it, it is actually a piece of work that is actually handed over commercially for sale and for selling. Now, if we look at the time scale now, I wanted to show you another innovation we've done just recently, which is our next area, which is called Croc Spotter. And the reason for that is that we actually got contacted by the Queensland government that they have a crocodile problem. So we already solved the shark problem. They wanted to see if we could also spot crocodiles. And interestingly, Crocodile Spotter is actually also applicable, I believe, in India. So it's an area where we believe we can actually be very, cooperative across countries here. So we got some initial R&D funds to develop the initial R&D. We then conducted some trials. We did the first ever live stream of Croc Spotter at the World of Drones Congress in October 2019. And of course, we used the launch of our software as a service, our cloud solution, using SaaS AWS. So to give you an idea, here's a video. Hopefully you can see that. This was just some demonstration. This is obviously not the sea. This is now in an estuary, a riverway, or it's some waterway within Australia. It can actually, by the way, interestingly, crocodiles can come to the beach in the sea. So it is very possible for them to come and actually come to the shoreline, which is very dangerous for humans. So although most of these pieces of footage are captured in riverways or waterways, which is mostly where crocodiles sit, the actual application can also be used on the beach as well. But this is mainly non-beach type thing. So you can see there's a crocodile. He's being a bit distracted by the drone, most likely. That's why he's moving away. Normally, the crocodiles, they can sit there for hours in the sun, and they don't have to they don't have to move until they need to eat. So, but they're very hard to see. In some water, the coloration of the crocodile is very similar to that of the water itself. So as you can see there, I mean, in this this footage, very difficult to see. See, this footage is not so bad. There's a reasonable contrast between the crocodile and the water. Water's blue, and it's more closer to the ocean. But inside, these type of estuaries, that's where the problem occurs. So this type of situation. Now, it's okay when they're on the land, but once they go into the water, that's where you get the biggest challenge for these. So that's the biggest work that we've had to do, and what we found is actually quite different between sharks and crocodiles. Is that sharks, usually are visible beneath the surface of the ocean, but the crocodiles have evolved for many millions of years, and they have evolved to be part of their habitat. So obviously they have evolved in such a way that it's much more difficult to be able to spot them if this one here is submerged into this area here or along this bank here, it'd be very difficult to spot, because if it submerges too far down and the watercolor is too close, it'll be of a challenge. So this work here has been we continue this work. It's not finished yet. We do need to look at deploying it in a more commercial sense, but we're very proud that at least we've had an opportunity to do some successful testing of this work in Queensland. So the last thing I want to show is that what's the future for us? Well, we already talked about how we could, look at animals, and animals are very important because there is also environmental and safety considerations. But you can see here, hopefully you can see this video, and I'll just play it one more time. This video is showing a drone, and it's showing a bird flying at the same time. And as you can see, the technology here is not picking up the bird, but it's focusing on the drone only. So this is part of another project we're doing, and it's more in the area of security, of being able to detect drones from a certain period away. And also, there are many competitions available. We've been fortunate to enter a number of competitions, and we've published a number of papers on drone detection, also long-range drone detection, and drone detection in very difficult scenarios. So obviously the challenge here is not as bad because the drone has a very high contrast with its background. Although there is a bird, you can probably detect the shape of the drone, and you can probably distinguish between the bird. Where some of this new work we've done has been to look at trying to analyze, the drones in difficult scenarios where there's glare, where there is poor lighting, where there's too much lighting, where the distance is too far, from different type of ocular perspective. For example, is it a fisheye lens, or is it a proper lens? So we had all these different factors, and we found that there can be some very difficult problems for drone detection. But we are working on that, and as I said, we have a contract at the moment with an industry partner to develop some solutions for automated drone detection. So that brings me to the end of the presentation. I very much thank you for your attention, and we have, I believe, about 20 minutes left before the end. So I'm very happy to take any questions that anyone has. So thank you very much for listening to my presentation. Thank you.
Thank you, sir. It was really a very interesting presentation, which is a buzzword today. And we know because of the prevailing situation, COVID-19, we also know how much the impact the drone has done in every society and every circumstances that has supported us to be in a safe environment. We have some of the questions by our attendees that they have posed. The first question is, I'll just take up. Can the system identify that there is a shark before it comes to the view of the camera?
Right. So the question is, can the shark be identified by the camera or
by the system before it comes to the view of the camera?
Right. Okay. Now, that's a very good question. That's a very, very good question. Right now, our technology is based fully on visual analysis. So that means that all of our detection occurs on the basis of video imagery, but it's very possible that you could look at other image or other sensors to detect the presence of sharks in a different way. You could probably do, things like LiDAR, echolocation. You could find different approaches. Ours is only visual, but the interesting thing is it can detect a shark from a very long range. And the whole idea of the fact that the drone can fly quite far, I mean, it still can only fly as far as the eye can see, because we're only using line of sight drones. But that distance is sufficient to try and detect danger, to mitigate the circumstances. So there hasn't been a need yet to look at other sensors or other approaches. All of the detection has been done on the basis of some visual, but the visual can be tiny. It can be very small. So we can detect a shark quite a far distance away. And then even if it doesn't detect a shark, it might say, look, there is an object there. And then the drone operator will move so this is not an automated drone, right? The drone is controlled by an operator, and it can move the drone to the location and see, what is that object? So whether we detect an object or not, we can see it from quite a far distance, and the distance is sufficient to maintain safety. So in other words, for this application, we didn't need to have any other approach. It was sufficient to have it on the basis of visual recognition alone, but it's possible to do other things as well.
The next question is, sir, how long was the drone in the air?
Is it how long?
How long was the drone in the air? It's the flight time of the drone.
So these drones are very standard drones. The drones which are mostly used in this day and age are still very short. It is only approximately 30 plus minutes. But the interesting thing is that on the beach, we had many drones, right? So what we would do is we would send the drone. It would stay there for 30 minutes or however long. If the battery life was going down, it would then come back to the base station, and then we would switch either the batteries or the drones. And then you could go for another half hour. So the good news is, though, that drone battery life is actually growing in length. Okay, so there is some experimental drones which you can use with 4 hours life, and you could then really take much longer time to do the analysis of the water. But as long as you have a drone in the base station that you can switch, so one goes up, one comes back, you start charging it. But we have multiple drones in the fleet, so it's very useful to be able to interchange them. But if you didn't have multiple drones, that would be a problem, because it would exhaust its battery, and then you would have to stop. So it's very important that you have a process, either a changing process or you do some other method in between. But yeah, so that's the drone battery life is a challenge.
The next question is, can we use sonar for these applications?
Yes. As I mentioned before, apart from video, you could look at many different ways which you could try and find sharks. So, as I said, our next step will probably be LiDAR and hyperspectral imaging, but you could deploy sensors into the water to actually use sonar. In fact, someone was suggesting we could also look at underwater drones or underwater UAVs, which could also actively use sonar to detect prey. So certainly that's possible, and it might be something we will do for the future. But at the moment, as I mentioned, we will only be, we're primarily using visual type approaches. LiDAR is one that we're going to do next, and then we will also look at hyperspectral imaging as well.
So the next question is, can you give us an insight into the deep learning algorithms that are used in the shark detection?
So the deep learning algorithms are custom. They're custom built. Unfortunately, the algorithms themselves are sort of I mentioned to you that we had we had an arrangement with a company called the Ripper Group. So the technology is actually their IP. So we really can't explain, we can't provide some of those details, unfortunately, because of the commercial sensitivity of those. But I can say it is a custom built deep learning algorithm. It is able to distinguish 16 different objects. We used quite a lot of data, tens of thousands of data for training, and we used shark, dolphin, stingray. So basically, it's a standard for if you look at it at the highest level, it's a standard deep learning model that consumes a lot of data, and its output is the distinction between 16 different categories. And although we focused on sharks, you could get it to detect other things, and we have enough training data because we sent out the drone and UAVs many times to collect this data. So we have enough data to be able to undertake that work. But yeah, unfortunately, I can't go into the specific details of the deep learning algorithm because of the commercial sensitivity. But I hope that helps a little bit.
Yes, sir. And we have two more questions.
Please.
Can satellites be equipped with this technology to view and detect?
So that is a very good question. Our partner, and I mentioned this gentleman. I'll have please feel free to look him up on Wikipedia. He's actually the co-founder of the Ripper Group. He works with us. His name is Dr. Paul Scully Power. Actually, I'll show you if I can go back to my two papers. He is the co-author of our papers, Paul Scully Power. He is actually Australia's first astronaut, in fact, and he very much is excited about putting imaging on satellites. And he believes that, because he talks to us about this a lot, he believes that that satellite imagery is probably the future for many things. And satellite imagery with AI is even better because we can not only detect things, but we can predict things. The biggest problem with using satellite imagery for the shark spotting is that I suppose there is a certain distance and a certain level of accuracy that may or may not be possible. I mean, there are some very high-powered, high-quality satellite cameras and video processing procedures, and I'm very much aware that you could detect a shark from satellite imagery. That is definitely possible, given the quality of the technology that exists, particularly in security and dare I say it, spy satellites. But the problem is sometimes you need that local information because you need to have something that's closer, that is controlled by the lifesaver, so that the lifesaver can then quickly react to a scenario. So although it's definitely possible to detect sharks from satellite imagery, and you could put AI on top of the imagery, no problem. The challenge is the immediacy of being able to help through being able to look at what's happening at the local location. As I mentioned, one of the rescues that occurred was because the drone was flying right over the two people that were drowning, and it could deploy the payload, and they were rescued. So that's something you can't do at a distance. You've got to have you've got to have it closer. But to answer the question simply, absolutely, satellite imagery can be used. but it probably might be more effective in different applications. So that would be my response there.
Yes, sir. We have a question from Dr. Bhatt from SJCE. The role of image acquisition and image analysis in intelligent system of your work and the decision on the algorithm that has supported them. Can you just throw a few lights on that, sir?
So firstly, the imagery, the images and the imagery, is that right?
Image acquisition and image analysis in intelligent system.
Okay, so the image acquisition occurred on the basis of flights that were conducted by the UAVs. So they were acquired from video footage that was undertaken over many runs. So the Ripper Group, who's our company collaborator, deployed these drones that were sent out by the lifesavers. Actually, many times it was the lifesavers themselves or the lifeguards, and they were collecting the footage. So the footage was raw. We did have to pre-process and do some analysis just to ensure that we had sufficient, samples. So we actually had to, validate the samples. The process of actually, we didn't need to do much processing of the raw images, but in order to tag the images, we did have to do some manual labeling, right? So that was something we had to do by a human, because the video was actually, we actually used it raw. There was no need for us to do any real major pre-processing, but to categorize the different parts of the image, whether it's shark or that had to be done manually and then labeled manually. Okay, so the annotation part was manual. The rest of it was all footage that was acquired automatically with very minimal image analysis and processing. And then what we did was we took all of the annotated, so we had annotated and also non-annotated images. We took all the annotated images and we applied it to the deep learning system over many different experiments and iterations. I mean, I didn't go into the details of that. As I said, some of the problem is that we can't disclose some of the specific details, but suffice to say that the training occurred on the basis of probably, I think, around 40,000 images, and we needed to train it on a heavy sort of heavy system. It was a NVIDIA GPU-based system, and we actually had to conduct many experiments to get the results. But of course, we were able, pretty quickly to get pretty good results. I mean, to get to 90% or above 90% didn't take us very long. When I say it didn't take us long, I mean in terms of overall, the overall problem. Usually, sometimes you can be there for many, hours and days and weeks. But we actually had very good footage, and the footage that was captured was acquired by our team, and they knew what they were looking for, and the training converged pretty quickly, and we've got some very impressive results for that technology. But we've always been improving, so we've added classes, we've added different images, different things like drones and humans, and in that scenario we did have to retrain. Okay, but basically then the AI system sits either on the box or in the cloud, and then when the drone gets deployed into the beach, it will get the image, extract it, and send it either to the cloud or to our box, and it'll perform detection and recognition automatically, and that is instantaneous. In fact, the cloud element of our system is actually the latency is very low. We only have 1 or 2 seconds latency, so we're very fortunate that we've been able to adapt the box and make it a fully fledged cloud-based system. So I hope that answers the question.
Yes, sir. And the next question is also very closer to the same what you answered now, whether the processing was done remotely or on the drone, whether you have answered it. So you have already answered that question. We have a very
Yeah.
interesting. The last question is by our director, Professor T.J. Ramurthy, who has listened to your speech throughout, and sir has really found it very interesting. So, sir, because we have many projects running in our institution, our young budding engineers, our graduates are trying out multiple things, and even the research scholars are working in the area of drone technology, basically on computer vision, because assessing the video quality on the drone is really a complex problem now because of
Yes.
the quality, because of the weathering conditions, and all those things. Sir is really interested in knowing whether we can do a collaboration with you to take up some projects which will help our students to be assisted in a very good and well-formed way.
I wanted to thank the director for very nice and positive comments. I'm glad that he enjoyed my presentation, and I would absolutely value the collaboration. In fact, we already do some collaboration with some Indian universities already. Obviously, we have connections with different universities in India, and UTS has connections with different universities. It has a number of list of universities, but if there is genuine interest from the graduates, from the scholars, we would be more than happy to look at how we can collaborate, and maybe even try and have some of the scholars at your university do some projects with us. So I would be very interested to have a further conversation about that, and I really appreciate the question. So thank you.
Thank you, sir. On behalf of B&M Institute of Technology, the family which we have formed for the Knowledge Hub and the facility that we have given for the graduates and research scholars, we thank you very much for accepting our invitation and delivering a very interesting talk on the very buzzword of today, sir. Thank you very much, sir.
Thank you very much, Professor Gowda. Thank you for inviting me, and it was my pleasure to present today, and I look forward to maybe meeting you, hopefully in person one day again,
sir.
and meeting everyone else from your university. Thank you for having me. I very much appreciate it. Thank you.
Thank you, sir.
Have a nice day.
Thank you. Wish you the same, sir.
Bye-bye.
Bye-bye.
Bye. I very much appreciate it. Thank you.
Thank you, sir.
Have a nice day.
Thank you. Wish you the same, sir.
Bye-bye.
Bye-bye.
Bye.